So this is joint work with my master students. They have all graduated in January, Vicente, Pablo, Ivania. And this work is about the recommender system in the art domain, and particularly the effect of explanations and algorithmic accuracy. So we have seen a lot of work in the latest years in movie recommendations, in music recommendation, also article recommendation, but not much on the art domain, artistic domain. And turns out that the online market is pretty large. Although we had the big crisis in 2008, since 2008, the online art market has grown consistently. You can see the revenue there growing consistently, but recommender system could play a very important role in this e-commerce industry. And if you check the literature, actually there is not much work on online art markets, although there is literature in recommender system in cultural heritage and in museums. So actually, Laura Arroyo, she was part of the CHIP project, and she was the main author of this paper on recommending paintings from the Rijksmuseum. Very influential work. We also have works using tags, keywords, and other textual features. And also traditional visual features, which are usually used in the computer vision domain, but which are manually handcrafted, like calculating histograms of colors or local binary patterns, right? But in the latest year, we have had a big revolution based on deep neural networks. And computer vision is one of the most important domains in this area. So very few works have used deep learning methods for recommending art. One of them was the work of Knijnenburg and Macaulay in 2016, and our own work that we published in just the last year. So we have been actually working in this for around 2 years. 2017, we published the first algorithm that we were actually comparing different types of visual features and metadata. Then we created actually a hybrid recommender algorithm. We ran an evaluation offline, and we had 2 additional papers on these topics and workshop papers in ACM Rexis. But although we learned this, that the features that you learn from deep neural networks give us better prediction accuracy than features like these attractiveness attributes like brightness, sharpness, or colorfulness, we have this problem of explainability, right? Basically what we do here with the deep neural network, this is pre-trained with the ImageNet dataset. These networks actually have millions of parameters. So trying to find the right set of neurons or the maybe layers that could really give you a sense like maybe these layers are related to color or this other to texture is a difficult work. So you end up just using a representation which is like a fully connected layer which have certain numbers, and this is your representation of the input image. So the deep neural network, one big progress is that they learn the features. You don't need to like create them manually. And they are very good for accuracy, but very difficult to explain, right? Now, in recommender systems, the topic of explaining has been researched for a long time, right? The first paper in explaining collaborative filtering recommendations is from 2000 by the group of Joe Constant and John Reeder from Minnesota. Then Nava Tintarev and Judy Mastov, they did in 2007 a nice survey that is now part of the handbook of recommender systems. But despite that, there is little research on explaining recommendation of images. So gaining some inspiration from the talk this morning from David Gunning, they had these groups of algorithms that might have maybe very good performance, like a deep neural network, but maybe not that good explainability, or a decision tree that doesn't have maybe good learning performance, but have good explainability, the features, right? And the idea would be to move these methods in this direction. So in our case, we have in the y-axis here, predictive accuracy for the taste or the user preferences. And here we have an explainability potential based on what we can get from these features. So here we have the attractiveness visual features, and here the deep neural networks. And in our research, we want to investigate is there an effect on user perception if we provide a user interface with explanation on this method or on this method. So in the case of the deep neural network, we can produce explanation based on examples, like these images are similar to these other images based on some magical embedding, right? And in the case of attractiveness, we can produce explanation based on examples too, but also based on these visual features. We can actually tell this has this amount of colorfulness or brightness, and you like this type of level of brightness. But then we have this question, general question, which is explainable and transparent user interfaces are in general well perceived by users in this previous research of recommender systems. But does it matter to the user experience if you do not produce accurate enough predictions? And this is a critique I do to our research, that usually we say, okay, we are just using this algorithm, I'm going to manipulate the interface. But we are not sure sometimes that the algorithm is accurate enough in making good predictions. And my feeling is that if you don't go through this threshold of minimum accuracy, then whatever explanation you do is not going to work super well. Why? Because you are going to be explaining why your explanations are bad. But people want good recommendations anyway. So more precise for this particular job, we are going to provide 3 interfaces, 1 baseline interface without explanations and 2 with explanation, but with different levels of transparency. Which one would be perceived as more useful? We want to also see the interaction of these interfaces and levels of explainability and transparency with the content-based method based on these deep neural networks or attractiveness visual features. And we want to also build a model that takes into account these 2 variables I mentioned, but also domain knowledge in art and the effect on several variables like perception of relevance, diversity, explainability, and user satisfaction. So our general methodology takes into account collecting data from this website, online store UGallery. Then we implement a system which records user preferences and generates recommendations. Some of them are half explanations. And we conduct this user study in Amazon Mechanical Turk to assess the impact of algorithmic accuracy and explainable user interfaces on several user dimensions. So we have this agreement with UGallery. This is a company based here in California. And they mostly sell one-of-a-kind physical artwork. They also sell photograph, but their main business is helping new artists which don't have the money to create their own websites, so they can post their paintings here, and then the company would help them to find customers. Then we use, again, these deep neural networks and these attractiveness visual features. Probably most of you must be very familiar with this already, but just in case you are not, usually you take an image and then you pass a different window and you move this window. That would be like a convolution. You finally create like different maps, and then you provide certain pooling, so then you calculate one number out of these windows that have several numbers, and you process this in several layers. And then before you get to a final layer and you make finally the prediction, you have these fully connected layers, and we particularly use this fully connected number 6, which has been used in the past, and it's a vector of 4096 dimensions. This particularly is the AlexNet. There are a lot more newer network architecture, but this works pretty well actually in our previous work. And in the case of the attractiveness visual features in DAP 2000 and this was 10 or 9, I'm not quite sure. But Jose San Pedro and Stefan Sirsdorfer, they try to rank and classify images based on the attractiveness using photos in folksonomy, probably from Flickr. And And these features actually worked quite well in order to finish this tag, which most information retrieval type of task. So how do we generate this recommendation based on the profiles of the items? Basically, when a user clicks on an item that she likes, then we can compute the similarity of each image in the UGallery inventory, which is not very large, and then we can rank all the items in the end based on the similarity to the user model. This is done based on cosine similarity, and then we can recommend this top n. So it's very simple, and the only difference is that the representation in the case of deep neural network is this 4000 vector, 4096 dimension vector. In the case of the attractiveness visual feature is this 7-dimension vector. And to make the explanation, we took into account this work by Friedrich and Sanker, a taxonomy of generating explanations in recommender system, where you provide a white box explanation saying, maybe you like this item because it's similar to other items, or because it has these specific visual features. This is more transparent in a way. And this black box explanation here is more, I recommend you this because it's similar to these other types of images. So how would this look in our system? In our system, if a user, we are recommending this image, then we can say is 96-point-something% similar to this artwork that you like, and then we provide here a histogram of values of this artwork compared to this one. And if the user doesn't understand this, they can click on this icon and see what this brightness, sharpness, and saturation mean. So this is the white box explanation. The black box is this one, in which you have an item, and then you have similar images which you have already liked, which have certain level of similarity with the one that we are recommending. Running out of time, so I'm going to go a bit quick on this. This is the study procedure. We have the pre-study survey here, preference solicitation phase, where people have an interface similar to Pinterest, and they can scroll infinitely down and pick at least 10 images that they like. And then they are assigned to one of 3 possible interfaces. One in which they have no explanation, but they have to go to 2 interfaces. One where the recommendations were produced by the deep neural network, and in the other case with the attractiveness visual features, an interface like this. In the case that the user was assigned to the interface 2, they have explanation based on the top 3 most similar images, like this. And behind you can have in background the deep neural network or the attractiveness visual features. And in the interface 3, in the case of the deep neural network, we use the same model as in interface 2, but in the case of the attractiveness visual feature, we provide this interface where you actually see which features are being used to produce this recommendation. Okay, so these are the dimensions that we evaluate in terms of the post-algorithm survey and the NASA TLX to measure cognitive effort. I'm going to jump the demo. And here we have 121 valid users. It took them around 10 minutes to complete, this proportion of female and male. And they were pretty fairly familiar with the art and paintings. So in these results, I have here 3 rows. The first row is user interface without explanation. The second row, user interface with example-based explanation. And user interface 3 is user interface with transparent explanation. And these 7 columns that you see here, the first 3 are explainability, relevance, and diversity. For each dimension, I have the results with the deep neural network and with the other method. Then we have satisfaction with the user interface, intention of use, and trust on recommender system. And finally, the average rating from 1 to 5. So I'm going to summarize some results here. In general, the deep neural network is perceived equal or better than the attractiveness visual feature. So this is consistent with previous offline result. But in terms of diversity, we have that the attractiveness visual features are perceived better. This result is expected that when you provide explanations, people perceive the interface as more explainable. But this perception is significantly higher using the deep neural network visual features, which is a bit counterintuitive because this is the most explainable and transparent condition, right? If we check then the perception of relevance, here we are using in one column always the same algorithm. The only thing that changes is the interface. And this is very interesting because we find that people perceive the recommendations as more relevant. So they think we have a better algorithm. And actually it's the same algorithm, but here we are providing explanation. But it's only working with the deep neural network, not with the attractiveness visual feature. In terms of trust, this is interesting. We see no difference in terms of trust when there are no explanations. When there are explanations, we see that the deep neural network is significantly better than the attractiveness visual feature. And a similar behavior in terms of interface satisfaction and intention of use. Then we built this model, thanks to Bart and Martijn Willemsen, that provided it for the recommender system community. I'm going to go very quickly. The interface has a positive impact on understandability. Here we see that the deep neural network features have also positive impact on ratings and on understandability. Understandability, perceived effort, the cognitive effort, has a negative impact on understandability. And I'm pointing always to understandability because understandability has a big impact on trust, and trust impacts final user satisfaction. But user satisfaction is also influenced by the somehow experience with art, with understandability, and with the time that they spend on the interface. So to conclude, we somehow replicated the results of the offline study in terms of deep neural networks, providing very good representation for recommendations. Providing this explanation has a big effect on several dimensions evaluated. So this is supportive on our community, that is not only about evaluating an offline algorithm, the interface can have a big impact, but the results indicate that explainability has a positive effect on the user experience, but it's not always well perceived with additional transparency. We provide too much details and it might not work very well. Now, the problem is that I don't know exactly why because of this result of this research. And one idea I had is that from this future work, I'm going to pay attention to this one particularly, is that we need to test recent advances in, not all, this one. This is actually a limitation of this work. We didn't test if this way of explaining the attractiveness was really understood by the user. So maybe there was a better way to represent this, maybe with text, maybe with a different visualization. And in the talk today in the morning by David Ghani, he mentioned that when you provide a bad explanation, you actually can produce a negative effect. So maybe it's not just providing more transparency, maybe we need to really take care of providing more transparency and very carefully explain. So with that thing, I conclude. Thank you.
Hey, Denis.
Hi.
Very good talk. I have a question that's maybe not really a question, but a dilemma.
Yeah.
So I found it very interesting to see that the deep neural network actually benefits the most from an explanation. And I was thinking about it during your presentation, and I thought, well, that one is less obvious, right? The other one, I can also see, you know, like the contrast and the brightness and things like that. So I can kind of see how the simpler algorithm came up with the recommendation. So I don't really need the explanation. So the dilemma is, is it possible that algorithms that are more difficult to explain actually need more explanation? And if so, how do we resolve that problem?
Well, that's also related to something that David Gunning said in the morning, that if the representation itself gives you the explanation and you provide an explanation of that, then it's not useful really. And it can really hurt the final user experience. So I don't have an answer for that, but probably we need to conduct more research related to these two issues or dilemmas that you are talking about. Yeah, absolutely. Here.
Laura? Probably we'll have time for one more question.
Hi, very nice talk. I was thinking while you were presenting, maybe it's just an endless opportunity. I mean, it's just endless path to try to explain something that is so complex. But what appears to me is that we focus very little on actually the specific goals that users have on those websites. So it's not just recommending art. Why do I go on a website of a gallery in order to get art recommended? And in many of those cases, they're very limited tasks that we know people do, to buy art, to get inspired for something, and so on. Wouldn't it be easier to actually try to match the explanations depending on what are the goals of the users and develop interfaces which actually extract easier those targets, user targets? And then once I know what I'm once you know what I'm doing, it's much easier to just give me this piece of explanation that fits my goal rather than try to explain why did you recommend me this thing. And then the other comment I have is that we did some research with curiosity, and there seems to be quite a lot of correlation between recommendation explanations that trigger curiosity. So curiosity and relevance seem to be very correlated. So if you include something in the explanation that will trigger your curiosity, people stop judging whether this is a good explanation or not. They just get triggered to explore by themselves, and this takes the responsibility from you to give them everything possible and makes them responsible to get satisfied from by browsing through the content. So it might be another thing you could consider there.
Yeah, there are several things. What you mentioned, in a way, is related also to this need for cognition that Martijn was mentioning. But one important thing you mentioned is that when we developed the model, the original evaluation, we did it with user transactions. They were buying actually paintings. And at one point, we had a small effect, but significant, of the price. Because maybe people were in a budget and then they couldn't just buy the painting that they really liked. But in this user study, they could just click on whatever, and we were not even showing the price, right?
Exactly.
So we were wondering when we were building the next, because now we are building, that's part of the future work, a full end-to-end deep neural network model. And here, it might be that you need to include the price if you are considering that the user is going to buy something, but if he or she is just liking, you don't need to. So having a good idea of the type of action or intention that the user have might be very important finally in the system. So I agree with that.
Yeah.
Thank you.
Okay, maybe one last question. Okay, just two last questions. All right.
Have you thought about where metadata might fit into this? Like if you knew the artist and the date and the style and things like that?
Well, yes. I invite you to read our the journal paper. Actually, we did a comparison of not only these visual features, we used the metadata that the company had. Now, the issue is that the company had, for instance, the painter for all the paintings. But for instance, the style, they had it for half of them. And then for other types of metadata, colors and stuff, they had certain, not all. So one proxy task first could be using this deep neural network just to predict that metadata. But what we found is that only knowing, at least in the transactions, right, which artist did you buy before, you could very easily pick the next thing that you are going to buy. Even better than deep neural network, right? That's a super powerful signal. And turned it out that then when we build the second model, we just force it to learn the artist, not only the embedding of that the initial neural network gave, and that increased the results significantly. But on the other side, for the company, it doesn't work recommending just from the same artist, because they want new artists come and have their things solved. So you can have like a out-of-the-box solution that works pretty well, but then you are not really helping your purpose as a company, right?
Okay.